Hello, chat. Oh my gosh. Damie, you are my driving podcast. None of the music I like sounds good right now. That's so real. I'm just streaming right now, and it's very funny. They're playing... I was about to say they're playing Roblox. They're not playing Roblox. They're playing Terraria, but on some difficulty where whenever you die, you drop all your items. And they're being very zen, I swear. It's very hard. I don't envy them. Although, for me, this is my hardcore Terraria right now. This is my hardcore Terraria. Guys, oh my god. My everything is breaking, don't worry about it. That was actually a bad crack noise. Guys, I'm gonna be so real. I am not prepared for EE. I'm going in, I'm like, does this battery add to this thing with superposition? I don't know. I don't remember. I wasn't taught very well. I turned into a ghost. I'm like, ooh. Anyway, we're gonna try. Okay, this one, I feel like I can do. I feel like I can do a little bit. So, we're working on diodes. And diodes are sort of... I feel like the best way to think about a diode, because they always say like, okay, diodes, you know, only let current flow in one direction. And I mean, I guess that's kind of true, but when you're thinking about diodes not in an AC circuit, it's kind of like, why would that care? Just got done with thermo exam. Oh my god, dude, I'm so cooked for my thermo. I'm actually so cooked. It's week 2 for us. He started teaching us kinetic energy. He ended lecture 20 minutes early and he taught us about kinetic and potential energy. Oh, we're not fucking learning thermo this quarter. We had 2 hours, I finished in 50 minutes? Oh my gosh. It's a lie. Oh hell no. Literally, it's the only time I ever, I looked around the classroom and I locked eyes with this one guy and we both kind of just shook our heads, it's so bad. It's so bad. I can't. Wait, so are you working with streams of mass flow going into and out of a system? Well, we've learned what Newton's second law is. We haven't even done anything yet. Streams of mass flow going into and out of a system, I've done that because that was fluids. But other people haven't taken fluids. I feel so bad for them. Because I'm like, what are you supposed to do? What the fuck, bro? I mean, okay, it's only week 2. And I also look at the textbook and he's teaching directly straight out of the textbook. So I think he's just doing a section of a chapter each lecture. But I don't think that's going to work when it gets harder than the most basic thing ever. And he's done one example problem that's plug in these numbers into this really basic equation. I'm like, okay, bro. All my classes are actually kind of easy. Even quantum. Quantum is straight up a math class. Well, that's good. That's awesome. I'm glad that you feel like they're easy. That's great. It just means that you're good. Most of the time we just neglect changes in kinetic and potential energies. Ah, it's been a while since I've taken quantum. Oh my god, I'm the only guy who answers my thermo professor's questions. And he was like, what does conservation of energy mean? And I was like, oh my god, are we 3 years old right now? But I was like, oh, energy can't be created or destroyed. And he's like, that's kind of true, but... And then I was like, oh yeah, you want me to say E equals mc squared also? You want me to say that in a thermo class? Okay, bro. Oh, in thermo? Neglect? Yeah. You can neglect, gravitational potential energy changes. We did that for pipe flow. And then, kinetic? Kinetic energy changes? I guess by shear, do you mean? I'm saying that from fluo perspective. Fluids for fluo. Fluids, where it's oh, we don't neglect, the friction changes. You got a girlfriend? Let's go, Pog! No way! Wait, that's so exciting. That's so fun. Good for you. It's always nice to have is it someone in your major? Because I feel like the most fun is when you have a partner that you can talk about your major stuff with. Oh, engineering at least? Yeah, that's also... She's pretty smart. Oh, that's dope. Wait, you're chemical engineering or BMed, or I don't remember. They all kind of blend together. All right, we gotta sketch the input. Wow, that's bad. Chemical? Oh. Kind of awesome though. Okay, 12, we need to figure out, so 12 volts RMS. This is gonna be, we need to figure out what the peak is. I drew this line wrong. Fuck. We haven't done anything to it yet, so it's gonna be like that. Actually, I feel like diodes are pretty cool. I also, my professor's kind of growing on me. She's kind of funny. She's like, she just says some things where I'm like, that's, she's really just kind of straight up. She's like, oh, why don't we want to like choose this bigger capacitor? Because it's huge and hot and very expensive. What's this class for? Baby circuits? You're so mean to me. You're so mean to me. It's circuits 2. It's slightly less, it's toddler circuits. No, it's like diodes and what's the like bipolar junctions. I don't know if that's what they're called. It's by something. I heard circuits isn't that bad. It is not that bad, but it can be really bad. It can be, I think it can just be frustrating. Cause like, part of why I think it's frustrating is it's very puzzly. Neonatal circuits. Anaconda for what is that? What even is that? Anaconda? The operating system for AI? Wait, a distribution of... Wow, that's crazy. Distribution of Python and R. Wait, that's fine. That's just Python and R. Because RMS is like 1 over root 2. So wait, we divide it by root 2? Or, I think we multiply by root 2. Times root 2. V peak equals something. Oh, spider? Wait. My ArcE friend uses that. We just use only MATLAB. We don't use anything else. 12 times. I'm excited for my MATLAB class tonight, but also I think it's really funny because he just straight up has not opened the canvas for anyone, and I was freaking out because I was like, dude, I have all this shit due, like we have like this on-ramp due, we have this other stuff due. He hasn't opened the canvas, and like everybody else must have turned it in, and he's not gonna let me turn it in late. And then I texted other people, I was like, hey, so can you like let me know if there's other stuff due? And they were like, he hasn't opened the canvas yet. I was like, bruh. I just started mine. Rev is on semesters, like Beetled. But for me, I'm taking Thermo 1. I'm taking this circuits class. Taking an intermediate dynamics. So intermediate dynamics is kind of like, how do I describe it? Like just 3D dynamics, but also rotating axes and other stuff. And then, alright, this is VS. T, I gotta put the period on here. And then, what else am I taking? EE. Oh, I'm taking a strength and stiffness course. So kind of like stress and applied stress analysis. And then, what else? I think that's it. I'm taking 4. Strength, stiff, EE. Intermediate dynamics, thermo. Yeah. Materials and stuff. Yeah. Like, kind of like FEA, but I don't think we're doing a lot of FEA. It's a little bit of FEA. Intro to FEA. Finite element analysis. Which I think is kind of funny because it's... I didn't realize that it was like kind of similar to how just like Blender does simulations, and I'm like, oh, if I just think of it like a Blender simulation, then I don't really have to worry about it. Right, I think this frequency is 60 hertz. So yeah, 1 over 60. So we've got, and then this times 1,000. 16, so this is 16.6 milliseconds. You're taking transport? Or are you taking thermo? No, you're taking thermo. You already took transport, maybe. The output voltage. Okay. You sold in transport? Oh no. And we have this type of deal. It goes through 2 diodes, so we have to adjust this voltage. I think it's a 0.6 offset. So when we have each diode sort of needs a certain amount of voltage to turn on, so it kind of takes away that voltage from the circuit. I got a 78 on my first exam because that was when first me and my Jeff were staying asleep deprived from staying up too late. Oh, 78 on your first. That's not even that bad. That's actually not that bad. I'm not gonna lie. Average was 90. Well, I mean, okay, well that's not great, but like, dude, my first thermal quiz, we have a quiz next week and he hasn't even taught us anything and he said it's no calculations. I'm like, dude, what the fuck are you talking about? He's, I don't know how this guy's able to teach. I gotta multiply this again because I forgot to hit the enter button. This, and then minus 1.2 volts, so 17.77. Sorry, 15.77. I mean, I could say that this is 16 point, what was it, 16 point? Pretty close to 17. Back to back to back, 3 hours of sleep, oh my gosh. Not good, not good. Gotta get that sleep. Very important. Where the, what the, where the, what the... Was it, why was I doing that? This divided by 2. I really don't know why I needed to do that. I didn't need to do that, but it's fine. 8.33. There we go. Yeah, our diode. I love a bridge. I got so scared of the bridge rectifiers, but now that I know how they work, I'm like, this is awesome. I like bridge rectifiers now. So for this part of the cycle, we have the positive going this way. So it's gonna go into this diode and into this diode and then back around. So that means that diode 1 and diode 4 are on. And then when we have the negative, it's gonna go into this one. And it goes into this one because it can't, well, because the option is if it goes this way or if it goes this way. And it goes this way because this one is not on because of the voltage setup. So this one is on. This one is diode 2, diode 3 on. Yeah, so we lose a little bit of voltage because it goes through. Should I get a coffee before my quantum at 6? Oh my gosh, I have a 6 p.m. Riding my bike at 6 p.m. and it getting darker and darker and darker and there being less and less lights on the road makes me terrified. I would say get a coffee. But it depends on how late you want to sleep. You still have homework due tonight? Do your homework! Do it right now! Frequency of the which are in the cycles of V. What the what? Wait. Appropriate cycles of VS2? I don't know why it's VS2. I'm trying, man. Wait, you had thermal exam? Oh, you're fine then. Give yourself a break. If you had an exam, I didn't realize you had an exam today. Wait, you said it earlier. I'm literally just dumb. Okay, so now we have to sketch. Wait. Wait, did I fuck this up? Get to the output voltage VOT. Uh-oh, wait a second, I might have fucked this up. No, okay, there's no capacitor, we're chilling. Now we have to do this. Alright. This is the part that I started doing, and then I just didn't do it. So, I think the way they want us to do this, somebody was asking this in class, they were like, how do you know where it crosses? Because, so we have our initial, so this is the voltage that we've got going in. But we want this to be kind of like a line, because we're trying to convert AC to DC, and we had AC up here, and so first we had to get it up here so that we could convert it to DC. But now we have to use a capacitor to filter this out, because as the capacitor charges up, we'll give it some voltage, and then as it discharges, it's gonna discharge slower than this sinusoidal wave. So we're gonna be able to retain more of that voltage. So we have to draw the capacitor basically. And I think we're just gonna draw them on top of each other and do that. Quantum is so free because these chemistry majors don't know how to integrate. That's so funny. I swear to God though, like, oh my God, as a mechanical engineer, they don't make us integrate enough. I know that sounds like kind of awful. I'm like the guy who's like, didn't we have homework due, professor? But like, these people are gonna go into industry and they're gonna be like shit at integrals, and it's like, guys, you don't want to be shit at integrals in your job. Like, be shit at integrals in your school so that you can like slide by and be fine with it. If you come and you're like, oh, sorry, I integrated this wrong, they're gonna be like, what the fuck are you doing? I've used in CMOR calculus and quantum that I've seen in calculus. That's beautiful. I think the lab that I have tonight, it's an activity for intermediate dynamics. It's supposed to be a lot of differential equations, so I'm very, very, very excited. I asked the professor, I said, hey, professor, he's a grad student. I said, hey, is there any practice that I can have for these differential equations? He said, nope. I was like, okay, I see how it is, dude. V over a capacitor. Oh wait, I know it's no, not QVC. Hello, I want the one that's RC. Oh, come on now. Yeah, engineering surprisingly doesn't use that much math. I guess that's a lie, but it's also not a lie. You go into engineering, you're like, man, I love math. I can't wait to do math. Well, a lot of engineers don't say that. But some people go into engineering and they're like, I want to do math. I love it. And then you go into your class and you're like, so where's the math, guys? Where's the math? Alright, I think the V on the capacitor is V initial e to the negative R1 over RC. Oh. Negative T over RC. Okay. So I have to try and sketch this. So we don't really care about the V initial. Well, I guess we do care about the V initial, but we know that it's going to start here. Let's say VC of T equals V initial times e to the negative T over RC. So the bit, this whole thing is 8.33, so we know that at least down here, the part that gets a little weird is when it starts charging again. But I think we might just be able to add that. So I'm not actually sure. I don't remember what the voltage. Well, we'll figure it out. It's it's 8.33 divided by 2. That's how we know what the discharge period is. So 4.16 milliseconds. So V initial equals 15.77 volts. And then I guess V after V 4.16 milliseconds equals, then we can just do this, 15.77 times e to the negative 4.16 milliseconds over 1,000 ohms times 8 microfarads is 10 to the negative 6? Oh, fuck. Is that million? No, yeah, microfarads. Let's see if that makes any sense. I don't know if that's gonna make any sense. I probably should be doing this on a real calculator. My toxic trait. I always ask my friend, I'm like, hey, can I borrow your calculator? I don't want to get mine out. She's like, Damie, please. Wait, 10 to the negative 3. Yeah. Yeah, this is getting unwieldy. One sec. I'm gonna try it though. Okay, 0.59. That actually isn't too bad. Well, this and then times 15.77. 9.37 volts. So that's how much it's discharged. So if it's 15, half of 15 is like 7.5. So it'd probably be, let's see, what's a fourth of 15? Oh, 3/4 of 15. Wait, what? It's not 20. 11. It's like somewhere in here. Like that, I think. That seems like kind of a lot. Oh wait, no, I think we're okay though. Because then it goes like up and then down. Like, yeah, there we go. Okay, chat. Now, does it look beautiful? Not really, but it's fine. Don't worry about it. Let me make a bigger brush here. Oh, that's too big. She looks at this, she's like, what the hell is this guy doing? I think it's close enough. Work smarter, not harder. That is sort of what it's supposed to do, though. Cool, and then repeat part B with capacitance equal to 100. Easy. I'm gonna need my calculator for this one, so we can just get it. Now, if I could do this with MATLAB... Oh, I should probably turn in my my MATLAB thing. Doing that last time, that was so cool. I just feel so cool when I get to graph stuff on MATLAB and I write little programs and stuff. I don't know, I always mess up the numbers, but not the equations, so when I get to write MATLAB, I'm like, ooh, I'm getting it right, that's like cool. Alright, so we have, let's do the negative part and then I'll put it to E after. So negative, I guess I could just put it to the negative that after. So 4.16 times 10 to the negative third divided by 1,000 times 8 times 10 to the negative 6. Now it's not 8. Well, I guess I could check that it's right first. E to the negative this. Yeah, okay, cool. We got it right. That's awesome. Now it said with 100. Do that. That is not what I meant to do. Okay, and then E negative. Ooh, okay, this one is gonna be really big. Oh, but that's good, because then we can say 15.77 times this. Ah, okay, so this is how we see. So V 4.16 milliseconds equals 8.77 times 0.959 equals 15.127 volts. So now we can kind of see that if this is 15.77, when we get to here, I guess that isn't really where that is, huh? It's more like when we get to here and then we can extrapolate it. We're basically only losing like this much. So we have something kind of like that. And we have this really nice, more even little curve instead of that big chonky curve. And we lost a lot less of our, well, we have a more stable thing here. It's a closer approximation to the DC power. Now, it's so interesting because I think we're going to talk about the optimization part of this in my lecture tomorrow. But it's really cool because so you can choose that capacitor, right? What we don't choose is this is our wall outlet. So we take AC power. We don't get to choose that. These diodes we get to choose, but the diodes, I mean, we can choose the offset of them, but usually the offset is 0.6 volts, so we only lose a little bit, but that's kind of whatever, because it's like, whatever, 0.6, we don't care. If it's 120 volts, like, whatever. And then this is our load, so we also don't choose this. And the load makes this, if we have a smaller load, then we'd have a bigger voltage. But it's cool because then it's like you get to choose the capacitor and figure out how much of this percentage you want. So it's just like how much do you want to drop down and how kind of like noisy do you want your DC to be. But because then we have to do other stuff to it. But you know, if you're making like a little toy or something, it might not require as clean of a signal. So that's that one. This one, okay. I don't know, I'm gonna try. I understand, so zener diodes. I guess we should like talk about maybe what a diode is. The diode is a little guy, and it's comprised of a semiconductor. Two different semiconductors, actually. And something about semiconductors is that they're kind of in between a metal and a non-metal, which is why they semi-conduct. And the special thing about semiconductors is we can change how much they conduct. So essentially what we do is we dope the semiconductor to make one side have more electrons and one side have less electrons, or like more holes, missing electrons. And then when we put them together, we can create this thing where the electrons when we have a lot of electrons over here, they want to move into this side. And when they stabilize out, it kind of creates this wall where, because we've set this up like this, we want, it only wants the current to go through that way. But with this little guy, a zener diode, so yeah, generally your diodes, the whole thing is like they take current one way because of that. But with zener diodes, if you give it a high enough voltage the other way, you essentially, it's like, no, I don't want to do it, no, I don't want to do it, no, I don't want to do it. Okay, fine, I'll do it. So if we run a high enough voltage, we're able to get a reverse polarity, reverse bias, and that is what the zener diodes are for. And so the cool thing about the zener diodes is that they, with our other diodes, right, we have like that offset voltage where it kind of, it takes that 0.6 volts and it's like, okay, I'm only going to take 0.6 volts. I don't really have like any resistance or anything. It's just kind of like a gate or switch for the current to stop it if you have AC. But with a zener diode, the voltage across it is always going to be a certain voltage, no matter how much voltage you give it. So if you give it like 100 volts and your zener voltage is 10, it's going to stay at, that's a lot. It's going to stay at 10 volts. So kind of neat because we can use that then when we have this messy signal, right? If we have this messy single and we're like, ooh, we don't want it to be messy, we want it to be straight line. And this is like, maybe it's above 10 volts, right? And let's say our zener voltage is 10 volts. The zener, over this zener diode, it will always be 10 volts, because it's always above 10 volts, and it just only puts out 10 volts no matter how much you give it above. So that's what we use that for. So we do all the rectifier stuff first, and we do the capacitor first, and then we have this little dude right here, and he helps us straighten it out. But this question is asking for something a little bit more in depth. So the zener voltage here is going to be 14 volts. So this is 14 volts, and it's rated at 5 watts. So find the range of the load resistance for which regulation can be obtained if it's rated at that. So we have to figure out, basically, how much power we can pump through this stuff before stuff starts exploding. Or kind of what our load is going to be for that. Sippy. So the first thing we start with is saying we want to figure out currents. I'm back. I forgot my phone was dying and it died, and trying to plug it into my phone charger, I put that thing directly into my milkshake I had bought earlier. Oh. The milkshake does not provide voltage. I'm so sorry, Rev. That's so painful. Like that hurt me. Ow. Owie. That's fucked up. That's kind of fucked up and evil, I'm not gonna lie. I cleaned it good and it's okay, it still works, but that's so real. Oh my god, that would be so scary. You want your charged milkshake. You want your phone to go swim in it. As our power max is 5 watts. Now, what we have to say is that if this 5 watts goes all the way, if all of the current basically stays in these resistors, I think, this is me talking out of my butt. We need to find a max current for sure Z's. And the way that we do that is we say, because the one thing I don't know is like, I think it's if we're treating, the hard thing is when we did this, she did an example of this, but the example she gave, she wasn't changing this, she was trying to figure out how to spec this, and so it's like, I just don't know about the current division. Like, I don't know how the resistance over here, there's an example in the book, I'm just gonna look at it. Let's stop beating around the bush. Wait, where's my PDF? PDF editor. That's Discord. Not a PDF editor. Oh, it got moved. Oh yeah, I moved it. Sorry. Why did it get moved? I moved it myself, that's why. Oh my god, and it's gonna open in Firefox. Please don't open in Firefox. I can't edit it if it's in Firefox. Okay, there we go. Let me go down here. Discord should be a PDF editor. First ever actually useful update. I know, what if you could like do the little remix thing and then it was just like a PDF editor? That'd be awesome. We're going over here, chat. Oh, look at this. I started trying to annotate this. Here we go, here we go, here we go. To illustrate the operation of zener diode, unregulated source DC is regulated to the value of the zener voltage VZ. The diode must be kept sure, whatever, upside down. Also note that when that is in reverse breakdown, sure. 3 observations are I don't like reading EE textbooks. The observations are sufficient to understand the operation of this voltage regulator. The load voltage must equal VZ, sure. The load wait, so IZ is, wait, which R? Oh. Oh, I see. So... Okay. But I don't know if our I... Okay, so our I max then would equal VZ over RO, which is the load thing we're trying to change, which is 10 volts over RO. Is that true though? The output current is the nearly constant difference between the unregulated IS and IZ. Oh, so there's only a little bit of current going here. Oh no, this makes sense. Oh, okay, yeah. I feel like the thing that's confusing for me is that it's hard to not think of this as a oh, you can't see what I'm talking about. It's hard to not think of it as a resistor. It doesn't have resistance. It's just there. It's like a piece of wire, basically. So our Imax isn't this. Our Imax, we care about the power. So Imax equals Imax theater. P equals IV, I believe, right? Let me just check that. Power, I googled it already, power circuits equation. I think it's IV. Yeah, VI, okay. So this is how we get our maximum. So it's all of this current is gonna be the same here. Well, it's gonna split. It's slightly different, I guess. Okay. This is Imax. This is I load. Maybe that's how we do this. Maybe that's how we do this. Oh! Yeah, that's how we do it. Wow. Good morning, chat and cat. Good morning, and Stucky. How's it going? I'm fraud streaming in the math category again. Equals IV, so we have 5 watts over 10 volts equals 0.5 amps. That's our maximum power. So now we say that I max plus I load equals I source. Fraud streaming. I'm streaming EE, but I'm in math. That's why I'm a fraud. Frog streaming. Yeah, my new model, guys. I'm gonna rebrand into a frog boy. I don't know if I can rib it very well. Frog streaming goes hard as fuck. Hey guys, I'm sitting on this lily pad. Dude, I hated these imagine shade circuits. Like, what is that? I know, it's so hard. It's really hard. It's made even harder by the fact that, like, I was not taught it well, and I just kind of, like, scraped by, and I'm like, I think I know what maybe it is. So, the worst case scenario is if we don't have any load, or resistant load. So that would be I source equals, also what the fuck, how long has big water been there? I'm insane the whole time. I keep forgetting to turn them off. Big water's looking at my thermo being like, I'm so displeased right now. I source equals V over R equals 50 volts over 30 amps equals 5/3, which is 1.67 amps. So that's the worst case scenario, which is obviously not the same as our I max, but now we just have to figure out We just have to do it. This is fine. It's fine. It's fine. It's fine. It's fine. So 1.67 amps equals 0.5 amps plus V over R. So it's the same. It's in parallel. So 10 volts over RO. Zero safety factor. We don't gab about safety factors here. Wait, what's the easiest way to do this? RO, it's gonna be 10 over that. I'm not writing it like that. Just straight up no safety factors. We could choose a slightly bigger resistor and then we're, you know, maybe a little bit safer. Wait, what? Oh, 8 point... Wait, only 8.57 ohms? That seems wrong. The other ones are like 10 ohms. Okay, maybe it's not that bad. Maybe it's not that bad. We could say like 9. We could say 10 ohms and it'd be fine. I'm gonna say like roughly equals 10 ohms. Because you could buy a 10 ohm resistor, you know, and then we'd be way over. But that would be bad though, because then if we don't have a load, then wait, but I need the top. Wait, what's the max it can be? I don't know what the max would be. If we had a lot of resistance over there, then all the current would go through the diode, which would be bad. But if we had no resistance over there, then all the current would go through that, which would be fine. I think it's 0 to that. Because if it hits higher than that resistance, then this number would get smaller and this number would have to get bigger. So I guess 0 to 10 ohms? I'm gonna say that. This is rounded. Rounded for safety. Yeah. Maybe. I don't know. I feel like that's a little wacky. But maybe it's like... Because the one that... Wait a second. Let me look at real quick what they did. Because they did an example where theirs wasn't 0 for some reason. But maybe it's because it was like the resistor couldn't have... Since V is more or less constant, the power rating establishes an upper limit on the allowable diode current IZ. Yes. An upper limit. Yeah. When the regulator operates according to intended design, the worst case would sink all of it. Oh. Maybe it's not this. Wait, this is the exact same problem. Wait. This is literally the exact same problem. Wait a second. Uh-oh, chat. Uh-oh. We didn't do it right. This is the exact same problem. Why? Why would they have the exact same problem? Okay, sure, whatever. Find the largest and smallest quantities for the voltage really, and do not cause diode. Okay. Determine the minimal acceptable load resistance. The regulator can at most supply the load with the amount of current provided by the source. Oh shoot, I didn't get rid of the... Uh-oh. I didn't get rid of the Z. It's not all 50 volts. Because it's 14 is getting taken. Okay, wait a second. We have to update slightly. It's 36 over 30. $50 minus 14. This is not 1.67. It's 1.2. So then 1.2 over, what is that? 0.7? 14.28. So 15. Alright, let's see. Ready to fix that. I feel like there's gonna be some other stuff we have to fix. If the load required... Okay, so our minimum... The minimum theoretical resistance can be computed by assuming all the source current goes to the load, and the load voltage is regulated at the nominal value. Can I do that? I'm gonna leave my answer being wrong. But... Okay, so 1.2 amps, I got that. Determine the acceptable load rating. 5 over 14, 0.375 amp. How did I get that wrong? Well, okay, because I said it was 10. So that, that one I can change. I just got too used to saying 10 because... Okay, that's a little cringe. 5 divided by 14. 375. Or 357. So then we have to change that here. And here. Divided by this number. Oh, it's 28. Wait, it's not that. I lied. It's 1.2 minus that. Oh my god. It's also not 10 volts. It's 14. Every single number incorrect. 14 divided by 1.2 minus that. 16.61. I don't really know what... maybe 20. Let's say 17. Load must not require any less current. 11.7 to 16.6. Okay, so the 11.7 comes from if we didn't have a diode. We didn't have a diode? Can it most supply the load with the amount of current that can be provided by the source? Oh, it's just our regular... Okay, I guess this is... Chicken on screen! Oh my gosh, my chickens! My little guys. There's a yellow one, that's voltage. It's the circuits brothers. Voltage, current, and resistance. I want to redo all my... Here's my favorite son? That's fucked up. You can't be saying that. I don't have a favorite. I love all of them. Love all of them so much. I should replace all my redeems with just a library of little guys that you can put on screen. No more Drowning Friday, only Big Water shows up in the background for 3 seconds. I'm kidding, I would never get rid of Drowning Friday. Alright, okay. Put me up there? Okay, I'll put you up there. I do like your ads. I should have a little place. Once I finish... I've been trying to set up Warudo stuff. Ant infestation in the damie room redeem. Well, if I set up Warudo, I can like have stuff fall on me and, you know, a lot of fun things. Having stuff fall on me actually sounds scary when I say it like that, but I could have ant infestation. But that's a little like, that's like too rev core, you know, the ant infestation. But maybe if you like, if you clicked on something, if you found a special link and did it, then you could put ants on me. And make an ARG just so that we can put ants. I'm gonna put this on engineering paper just so that this guy feels a little bit better. Because he asked us to do memos, and then he did not. He was like, I give up, don't do memos. I just feel a little bad for him. Do it for me. I am never to return? Wait, what do you mean you're never to return? Rev graduation arc? No, I need to go on your stream and watch you play Hyperspace Outlaw or Hypnospace Outlaw for 18 hours, please. The 10 million? Damn, okay, 10 million resistor. Ohm resistor. Represents a scope input resistance. Calculate the voltage across the 2M resistor and compare to the ideal case. An ideal scope input resistance is the same as an ideal internal resistance of a voltmeter. Maybe I'm just a busy bee and socially died by the time school. Yeah, no, that's real. I mean, it would be hard for me to stream if I didn't stream things that I was doing for school. But it's a happy accident that that's the same thing, so. Okay, this I can actually do. This is DC, thank God. So let's start with REQ equals 1 over 2 million plus 1 over 10 million to the negative 1 plus 100k equals 2 times 10 to the 6th, is that the million? The million. I don't know what that is. Let me see. 1, 2, 3, 4, 5. Streaming my research and leaking all the participants' names. Legendary disaster. It's 10 to the 5th. 100k? No. Yeah? Yeah, 100k. Wait, it's just equal to itself? Wait, what? That's literally impossible. How is that possible? What the? There's no way that this number equals 1. 1 over... Oh, wait, oh, I might have, like, goofed it. 2 times 10 to the 6th. Plus 1 over... Danganronpa execution sound effect. I just like this soundtrack, and it's trying to execute me. End of the 5th. What the heck? How is that possible? Wait, oh. Wait, it's really small. Wait, no, it's supposed to be big though. Wait a second. It's supposed to be to the 6th, not to the negative 6th. Delete. This plus 10 to the 5th. This divided by 10 to the 6th. 1.6 million. That makes more sense. I was gonna say, there's no way that these... I guess I could have just done it in like, this is 2, this is 10, this is 0.1. Let's just check that. So, that'd be 0.5 plus 0.1 to the negative 1. And then this... Right? Yeah? And this plus 0.1. Wait, that's giving me 1.76. Chat, what do we think? I don't know. 100k is 10 to the 6th? Wait, is it? Wait, is it? Okay. No, you're good. I did that, literally did that so much. Like, that's my worst fear in EE, because one time I put like 10 to the 6th into a voltage generator, and it was 10 to the 3rd, and I was like, dude, I'm gonna blow this place up. Not into a voltage generator, it was a frequency sine wave thing, but I was like, I'm gonna blow something up accidentally. I think it's 1.6 million. It's either 1.6 or 1.7. I'm gonna say 1.7 million. What's the Bobo doll experiment? Wait, I just need the voltage across that resistor? I don't even need to do this. I could just do a voltage divider. Guys, I'm out of my prime right now. I'm not in my prime. I don't even know if I was in my prime for EE. You want to say V2M equals... Wait, but the ideal case is... Oh, do this. 2M and 10M equals sad music. V EDC times well, what's this 1 over 2M plus 1 over 10M over 1 over 2M plus 1 over 10M minus 1 plus 100k. So now we're back to this, which is 0.5 plus 0.1 to the negative 1 is, I'm just going to do 1.6 and then divide by plus 100, what's 100? 0.1? 0.94. Does that make any sense? That's saying it would have a lot more of the resistance. Wouldn't it have less? Because it has more? Chat, what's going on? What's going on here? Am I like... Like if you have two, a resistor with like 2 and then a resistor with like 1, doesn't the 1 have higher voltage? Wait a second. Wait, V equals IR. As resistance goes up, voltage goes up. Never mind, it's gonna be the same. I don't know, man. We're gonna just go for it. Do my best here. 14.124 volts. And then V2M ideal equals VDC times just 2M over 2M plus 100k. No, I did that. Times that. What? Wait, what? I just multiplied it times itself. It's one of those days. Equals 14.28. Okay, it's slightly higher when it's by itself, which I guess makes sense because it's slightly. Compare percent error equals R value, 14.124, minus the real value over the real value. Wait, what? That's such a tiny percent error. 1.129. I hope Rev is typing up an essay on the Bobo monkey, not Bobo monkey, Bobo doll. output ideal resistance is the same as an ideal internal resistance of a voltmeter. Bobo Monk. I sent him on Discord. Oh wait, what does he look like? I hope he looks very dapper and very awesome. I'm gonna put him on stream, so be warned. Wait, Discord. Oh, directly to me. Oh, wait, this is kind of science though. It's impossible to read, but you get the center of mass. These are like the twiddly widdlies. What are they called? Fuck, what are they called? Rocking dolls. No, rocking doll toy. With twiddly widdlies. Weeble wobbles, yeah. Weeble wobbles. Weeble wooble. Wait, these guys, wait. This is like the nicer version. Why do they suck so bad right now? Look at these. What is this reduce in quality? These are the ones that, like, I remember. Wait, I can't even click on his image. Okay, they don't, oh, that guy's scary. Wait, let me just go over here. Okay. Look at this decrease in quality. I just dragged the wrong thing. There we go. Look at this sucks. This is what I'm talking about. Weebles wobble, but they don't fall down, you know? The adults beat up the Bobo doll, and the kids watch and then beat up the doll. Blah blah social learning. Bobo doll just funny to say. I think I had this guy. That's kind of messed up. Why would they beat up the Bobo doll? Anaconda. I meant to click that on this. There we go. I think I would love the Bobo doll. I think I should leave the Bobo doll on my... I can't. Yes, I remember them. I know, they weren't great toys, I feel like. Replace the 2M resistor with a 100K resistor and calculate the voltage. Okay. Alright, chat, more numbers. Let's go. What is supposed to be the 10M resistor represents the scope input resistance? Okay, so... There was one where they were sweets to him, I think. They treat him differently, control group, and stand there. I haven't read the actual experiment in a year. That's real as hell. Times 1 over 100K plus 1 over 10M over 1 over 100K plus 1 over 10M plus 100K. Let's see what this is. 1 over 0.1. -1 plus 0.1. Lots of negative ones. And then this divided by... Ooh. That's a lot different. It's just referenced a lot with social learning, development modeling, and such. Psychologically, your EE stream, stay strong, the damer. No, it's beautiful. I think you should keep going. It's a place for all of us to talk about all of our little funny things. More chickens. Can we get a Weeble Wobble redeem? I don't know why I'm asking that. I'm the one in control of that. Chicken on screen. I love chicken on screen. What was that from? That was from my re-debut? Our Jackbox or something? I'm the sillier. I don't remember. Get Davey Virtual Weeble Wobble? Actually, I probably could do that. I think I could design a fun Weeble Wobbler. That's just 0.5, isn't it? Yeah. Wait, they're really not that... Yeah, jacking box. I sent that to my... That one file. And... Make Ethernet the wobbler. Oh, that would be so sweet. He would be so funny. Got so mad at Ethernet because we were using him to write a routine, and I've been biking to school, to campus, and I was trying to bike with him, and he's literally so unideal right now in terms of shape, and I was just like, oh my god, I can't do this. I can't do this, chat. Wait, why is the error less? Huh? Unbikeable. Yeah, it's because he doesn't have an actual bag. So when I took him apart, I just put him in like a tote bag, and then it didn't really work that well. Wait, box my answers. So 2M, so this is 100M and 100K. And this is just 100K. And this is, as a grader, it's really annoying when people don't box their answers, so I like, please box your answers. My other least favorite thing is when people submit multiple versions of the problems. I'm like, guys, I can't grade 2 versions of your problems. I don't even know why you think I could do that. Well, wait, it's 10M, not 100M. That's a very different. This one is just 2M. Okay. Man, I hope this class gets me like... Gets me so good at EE forever. I wish I could power up in EE. For which resistor value does the scope have the greatest loading effect? I've done that just so the professor could tell me where I fucked up, but also I'm accommodated. Well, that's fine if it's the professor grading it. Also, it's kind of different if I'm but also if they know you're gonna do that, it's a little different. But it's like I grade for this class where they do group quizzes, and so they work as a group, but they're supposed to submit one version of the problem. And then sometimes they'll just put all of their work in there, and I have to like go looking through it and be like, okay, well, you put 2, then 4, then 6, then 1. Like, guys, please. Never had a TA, just the guy. Yeah, it's so nice when people get things right when you're grading, and then when you look at the answer and it's wrong, and you're like, fuck, now I have to like think about how this is gonna work. Guy gender neutral, yeah, for sure, Z's. I should type this. They're gonna get mad at my handwriting like 1,000,000%. I'm not gonna write in Threat. What font should I use? I use Threat for a lot of my graphic design. I really like it. It's a good font. I just do... I'll do Dungshan right here. Use scary font. I do have Third Man, the monster of the week. 2M or 2M resistor is more affected by the scope. Why is it more affected by the scope? Is a great question. I feel like it because I think it's because I got rid of it. God damn it. The one thing I don't like about text tool and CSP. I think it's because it affects it similarly, but when the resistor value is really high, this is taking a lot of the voltage anyway. And so when it gets closer to this and it starts sharing it, then we kind of see the effect more, because use VT323. Is it in clip? Let me see. If I don't have it, I have wide Latin. the 2M resistor. Resistor is more affected by the scope, because wait, but that would make less sense, wouldn't it? Wouldn't you then expect? Because no, it's voltage. It's already. Wait, no, that would make less sense. You would expect it to be less affected. I don't know, guys. I don't know, chat. Literally, I mean, I see that as. I feel like I did something wrong. I feel like I did my calculations wrong. Let's just go to the next one. That's what happens. Teehee. Teehee. The resistor. Me when I resist current. Oh. What the? Oh, this guy is here. I was like, why is it? Wait, oh. Okay, there we go. Calculate the diode current and the voltage across the resistor. What TTRPG? Any TTRPG? Ooh. I think... Well, the one that I remember, what monster the weak type? Oh, I would be the weird one. The weirdo. They're like, I don't remember what it's called. The guy who has a high weird. Because I think that's like accurate. In D&D, I think I would probably be... I'd probably be a wizard. Like, or a... I don't think a cleric, because I'm too squeamish. I don't remember the difference is like a warlock studies from... One of them, like a wizard, studies from a school, and warlock studies gets their power from a god or something, right? And the sorcerer is like... Isn't a sorcerer like they have an animal? I don't remember. I think I would probably be a wizard. Whatever is the one where you go to school for it. Okay, calculate the diode current and the voltage across the resistor. What is the diode current if the diode is flipped? Well, wizard goes to college to get more knowledge. Warlock go to deity to get more piety. This is not how you... Me would piety. It's so funny. That's great. That's a fun little ditty. Alright, the diode current. Well, this is pretty easy. I equals... The diode is ideal. It says I equals V over R equals 12 volts over 2.2 K. I had to make it rhyme. Oh, you made it up? That's beautiful. I thought that was just like something people said. It's a very small... It's a very small current. Let me make sure that's right. It's been a really long time since I've done it. Yeah, okay. 0.0055 amps. Because there's no resistance. Warlock has specific paths with deity and rules, and in turn gets magic. Oh yeah. I think we had a chaos warlock for one of the campaigns for Spelljammer. If they go against the little guy, it's like knows magic for you, you die. Flipped I equals 0 amps. What is the voltage across the resistor if the diode is not ideal? So offset diode. VD equals 0.6 volts. So 12 volts minus 0.6 volts equals, I don't know, 11 point equals VR equals 11.4 volts. I had a clown warlock whose pact was with being I named well Germa Lolger many years ago. There was, I think my favorite D&D name was, there was a very short, it was a gnome with dwarfism, I believe. And his name was Sir Dabsalote. This was many years ago. It was not me, I did not play Dabsalote. A very long beard. VO for the above circuit if the... Oh, okay. We can do that. Alright, VO. So we're gonna basically... 21 sine 120 pi t. I think I'm working on Guy for upcoming campaign and edit with... Oh my gosh, Umbra raid! Thank you, Umbra! Hi everybody, hello! We're doing some electrical engineering. I hope your Terraria... How did your Terraria end up? Did you... I'm assuming you died more after I left. Maybe you won, maybe you started winning really hard after I left. I'm struggling over this. This is my Terraria hell. This is seriously epic. I got some pretty epic loot. Oh, ooh. From fishing or from regular? I don't know what regular would be. From the ground, I guess. I don't know how you can even get... Oh, from chests. Okay, okay. I was gonna say, I don't even know how you can get loot in Terraria. We should play Terraria together. I've never played it before. 12 volts is replaced with 21 sine V. So that's 21 is the peak. Wait, okay, so the positive is gonna be kept. So it's gonna be something like this, and then it's gonna stop, and then it's gonna go again. Go again. I heart chests. Whoa, whoa, that's kinda... You heart chests? Like Umbra saying they were play men. I clipped it. That's my one Umbra clip. Treasure. I think there was... Oh my god. There's this one game that I was playing with my brother. Some other people. It's this... It's like a communication game, sort of, like Codenames or whatever. And you have to like give a clue to a word, and I think the word was boo or something, and I think I said like, I think I said chest because it was supposed to be like, oh, boobs, with like a, you know, and then but he thought it was a treasure chest because we had like another word that was like pirate, and I was like, okay, yeah, that one's on me. That was a pretty bad clue. Boobs and boo are not the same thing. This is, what is this, V out? Yeah. Now I just have to get the period right. Sinusoidal period. I don't remember if that's the... I don't work with signs that much. Where is it? Where is it? Where are you? Where are you? C, phase shift left. What? No, B, period. Okay. So every 120 pi is a period. 120 pi. Be sure to label with numerical values, peak voltage, and period. What do I mean by numerical values? Oh, wait. Be sure to label with numerical values, peak voltage, and period. What's your question, Rev? Why so sneerious? Why so periodous? Why so jokerful? The smiling joker. Why so... Pino, my beloved. I haven't seen a Pino emote in so long. Ooh, question. Another question. Well, not another question, chat. I don't know if anybody has ever asked a real question with question. Actually, no, Blaine used to ask real questions with question. Shout out Blaine. I don't know if Blaine is just like dumb. I hope Blaine has been freed from classes. You know, it's kind of weird to think about, like, I'll have been streaming, like, next summer, I'll have been streaming for, like, 4 years. That's like, you can graduate in that time. Holy shit. It's kind of scary. 6, for problem in circuit, for circuit in problem 5, one multimeter set to measure default, what? When a what? That to measure DC volts is connected across the 2.2. Oh, it's just VRMS, right? I think. Oh no, it displays the half, which is... Oh no, wait, I have to... Displays half the voltage. That's the average voltage. The average is something. I looked it up and then I looked it not up. Uh-oh, it's gonna be a little bit of scrolling. I guess we could practice some of these. I should probably do that. Oh, well, that's not right. There we go. Where is it? It's in here somewhere. Okay, apparently it's not in here somewhere. Where was this? The yawner. Stop! It's afternoon, of course I'm gonna yawn. They did this out. Where did they do it out? Is it here? Oh, it was like A over pi or something weird. Damie yawn. Resident sleeper. Oh my gosh. Fine, I'll just never yawn again. No, not full wave. Oh, also my professor calls that full half wave, which I think is funny. It's full and half, guys. Don't worry about it. Where is this? Ah! I don't know where it is. Gone, it's gone. It's the ether. Wait, I could have sworn I saw this. Did I read it in the pre-lab? Oh, maybe I read it in the pre-lab. Here we go. Yeah, A over pi. I yawned so much I had my supervisor tell me it was rude, and I was like, what? Wait, but you're just sleepy. Yeah, I'm just sleepy. It's not because I actually don't care. I'm yawning, I'm the eeper. It's like warm and cozy, you know? That's crazy. That's actually crazy. A over pi. Is area just area? No, A is amplitude. But if it's connected across the... Oh no, we're chilling. Yeah, the voltage doesn't really... I have to, like, keep thinking that, like, diodes are basically nothing in a circuit. And then also, voltage doesn't depend on the resistance. Only the current depends on resistance. So just because... Oh, question, yeah, what's up? Garbage. Garbage. Garbage truck. I amuse myself, I'm sorry, what's up? Where am I? Hell. You're on the math side of Twitch. Welcome. Oh no. Actually, this isn't math. A lot of people would be like, oh, you're streaming in the math category? Oh, no, don't do that. Yeah, I'm a math student? Oh my gosh. What do you study? What kind of math? That's so exciting. This is physics, I'm mad. No, this is actually EE. Arithmetic geometry? Oh, that's so sick. Wait, I like asking math majors who... Wait, can I literally just flip this upside down? Do you think they'd be mad if I just took this picture and I flipped it upside down? Or... I'm not doing it. Wait, what? Oh. You're a PhD student? We have a lot... I'm gonna be so honest. I think it's really funny because some people are like... I don't remember what it was. I think it was maybe... Oh, there was like a Germa clip where he was like playing House Flipper. He's like, oh, people will be able to find a way to backseat anything. And then he's like, oh my gosh, I'm even playing House Flipper in the backseat. I'm like, Germa, like people backseat math. Also, is this Danganronpa music? Yes, it is. I think it's like... It's my execution is EE themed. I'm gonna make this smaller. I'm not gonna copy it. I'm a genius. It's good. It's good music. What can I say? There we go. Execution, if you will. The locusts consume me. I like the Danganronpa 2. I do too. I like to play 2 on stream. The music, not the game. I guess I could play Danganronpa 2 on stream. It'd be kind of funny if I played Danganronpa 2 on... Oh, I was thinking, I have Dream Daddy. I could play Dream Daddy this weekend on stream. If I don't have anything else to do, I might just play Dream Daddy because I think that would be really funny. It would be a little funny to play Danganronpa. I just think it'd be really fun to play Dream Daddy because I haven't played it and I haven't watched it in a very long time. Damie do it? Okay. Oh wait, this weekend is my birthday. This Saturday. I almost forgot. Dream Daddy. Yeah. Not Dangan. I mean, not that I don't like Dangan. But... Oh wait, that was it. Okay, we're done with that. Nice. Yeah. Oh, I just thought Dream Daddy might be fun to do a little voice acting. Because I don't get to do funny voices a lot. Oh yeah, I gotta write this. Let me just say. I don't love streaming in math because literally professors will come in and make me feel dumb. Wait, what? Professors come in? Wait, there was one professor who came in. There was one professor who came into my stream. I've only had one ever. And I started playing, because I stream math during like this quarter system, and then I play games normally during summer, and I do other sort of stuff. Like, I'm an engineer, so I do CAD and all that other stuff. And I think I was streaming with Umbra, and we were playing Minecraft, and he was like, you gotta surround yourself with real deal guys, not these people. And I was like, dude, it's the funniest fucking thing ever. Real deal guys. Like, to come into like a Catboys stream and be like a professor and like... I was like, oh my god, real deal guys was so funny. I don't think I've had any other professors, just like PhD students. But I mean, I guess technically doctors then, but I don't have it. I remember he would be like, oh yeah, undergrad people are so annoying to work with, and I was like, okay, sure, even though I'm an undergrad. Like, it was really funny though. I'm a professor. Lie. I love lying. I'm not really a professor, but I do teach people stuff. I disparage the undergrads all the time. It's fine. I was disparaging the underclassmen, but I don't really... They're fine. It's just that it's kind of funny sometimes when they're like, I want to do something, and you're like, you haven't even taken statics yet. Haha. Like, you didn't take dynamics. Oh, it's funny. I remember being there. I think I'm just jealous of their youth. I'm not jealous of their youth. I'm just like, sometimes there are certain classes, at least for engineers, where in the school that I'm at, it's like, it's just, you just have to take them before you can start doing stuff. Because you're like, damn, like, you haven't even taken mechanics of materials yet. Like, stress analysis. Okay, this guy's problems, wait, I just tabbed away from them. I was also in Mechie before I switched to math. I'm one class away from getting the degree. Oh my gosh. That's awesome. I don't really like Mechie. Well, that's a lie. I like Mechie. I'm just kind of a bad Mechie. Actually, I'm a pretty good Mechie. I just don't... Not in the way that people would want me to be, I guess. We do stress analysis in my major too, if you think about it. I like the way you think. Really, stress analysis is just like how upset materials are, if you think about it. My professor right now for FEA he's really fun. He's very deadpan, but he makes a lot of little funny jokes, and I just think it's really charming. It's very much my sense of humor. Alright, we're gonna try and do these even though I haven't done any of these and we haven't been taught anything but fucking Newton's second law. Do anxious people have high Young's modulus? You know, this is something that's just super random. We always called it the elastic modulus, but I know that it's also called Young's modulus, and I wonder if that's like... Is that just a depends on where you are in academia thing? Or is that just, like... I wonder. I think they would have a very low Young's modulus. Brittle. This material is so maladaptive coping with this stress. Sometime.s. I feel like I use both interchangeably. Yeah, that's real. I think it's just because we write it E a lot in my classes that they just call it elastic. That should not be a link. Well, it is. Too late. You got linked. It's like the opposite of embed fail. Bro, there's no way one of these problems is converting temperatures. Stop. Why? Why is he doing this to us? It's not on a string. Embed win. Really feel like that guy juggling the little, what's it called? The little tennis racket where he's like, it's not on a string. It's not on a string. It's just me, but with my... Don't teach us kinetic energy. Don't teach it. Alright, here we go. Gas enters a compressor that provides a pressure ratio equal to 8. Interesting. If a gauge... Bruh. This is multiply a number by another number. Damie juggling stream? When? When did I say I know how to juggle? I don't know how to juggle. I actually tried to learn how to juggle. I can't do it very well. I know the principles of juggling, but I haven't leveled up that skill yet. Oh wait, oh it's the guy. Well, I guess that guy did kind of juggle. This is just a ratio? Are you kidding me? This is gonna be the compressor. If the gauge at the inlet says this is 5.5 pounds per square... Oh, okay. It's asking for the atmospheric, so that's fine. PSI, and then this one's in pound force per inches squared, which is also PSI. God. Fine. Fine. E out equals 5.5 pounds. Wait, equal to 8. Exit pressure to inlet pressure. So it's 8 times. Guys, am I ever gonna learn thermo? Let's take bets. I think no. Thermo is fun. I really love fluids. I really, really, really love fluids. I think fluids is so beautiful. I'm kind of a little weird about fluids. We do a chat poll. Oh yeah, you want to do a bet? Wait, yeah, let's do a bet. Wait a second. How do I make a poll? I'll pay you guys out. Wait. I'll pay it out once I start. Like, let's do a poll of how long it takes me to learn for us to start doing thermo. Start a prediction. Name the prediction. When do I start learning thermo? Outcome 1, next lecture. Outcome 2, next week. Outcome 3, you don't. Name the prediction? I did name the prediction. Submission period. Well, okay. You get 1 minute to decide. Wait, I have to confirm the prediction within 24 hours, otherwise it gets refunded. Uh-oh, guys, am I gonna start learning thermo in the next 24 hours? I don't even have class then. This is the stupidest problem I've ever done. This is a strong contender for the lineup of problems that are genuinely the stupidest problems I've ever done. It's okay though, because they're almost done, so at least it's like it's not a lot of work. I thought thermo was gonna be like a lot of work, and then I had this. Alright, maybe this one's better. As shown in figure, air is contained in a vertical piston cylinder assembly fitted with an electrical resistor. Okay. I'm Sly. The atmosphere exerts a pressure of that, sure, normal, which has a mass of that and a phase area of that. As electrical current passes through the resistor, the volume of the air increases while the piston moves smoothly in the cylinder. Oh, okay. Determine the pressure of the air in the piston cylinder. Ah, nice. Okay. So how do I do that? I guess pressure is force over area, but can I just say that it's the force and then the area? I don't know if the... Oh, thank you for the follow, by the way, Garbage. I will hopefully be doing some math. There's some differential equation stuff, but I actually have to see today if they're... you think next lecture I'm gonna... Wait, what... Wait, let's see how this prediction... Where do I even see the prediction? You don't! Oh no. Oh no. Uh-oh. Check your syllabus. Check your syllabus? Yeah, it says start learning thermo. Wait, let me look at the... Let's look at the syllabus. It doesn't even have a syllabus? He kind of does. What do you want me to find in the syllabus? He doesn't say when we're doing things. He literally doesn't say when we're doing things. Course goal: understand the laws of thermodynamics and be capable of their application to engineering problems. Okay, properties of working fluids and fundamental relations for processes involving transfer of energy. First and second thermodynamic laws: irreversibility and availability. Usually minus are units and shit, that's so funny. Yeah, normally they do for me as well. This one doesn't. Yeah, Well, I think I might be able to see his lectures. Wait, maybe he hasn't posted his other lectures yet. Maybe there's a problem that says What about lecture 4? Is that the one we just had? Yep, that was the one we just had. Oh my god, I cannot believe he actually spent time, an entire lecture reviewing what kinetic energy was. Oh my god, guys. I'm cooked. Should I choose the prediction outcome? I don't know if I can choose it. We can't figure it out. Can I say, like, can we postpone it? Can, like, jury duty? I might have to look in the textbook for how they want us to do this. My guess is this. My guess is, if I draw my free body diagram, let's see the electrical current passes and the volume of the air increases. Cooked by heat in the oven? Like like thermodynamics? Yeah, what is the transfer of energy to Damie as he's in the oven? So we expand. I mean, I'm thinking PV equals nRT. Possibly, but we don't have any temperature information. We obviously don't have anything else information. Probably like 3. If it expands, I mean, it has to have a pressure larger than the... I guess maybe that's what it's saying. I kind of just feel like it's this. Isn't it just the pressure from the weight and the... Yeah, that's kind of what I was thinking. I would have recognized the... You spoiled it for me. I would have gotten it. But yeah, well, forced PATM, I guess. For being... Lol. But this is so easy, and also we had a problem that was exactly this. That was this problem. Oh my god, chat. I'm dying, chat. Sorry, no backseating. No, you're good, you're good, you're good. That's really funny. That's maybe the first time somebody's ever actually said something before I've done it on stream. Except for Storm, who is a math major, who was one of my first viewers when I was doing my calculus still, and would just instantly solve all of the math problems. For like multivariable and stuff. Oh wait, does it want to engage? Well, we don't need to worry about this. I guess I could write it like that. That's really fine because I'm gonna work engage. Assumptions. Should I say assumptions? I could be the worst ever. Incompressible. Well, it's not incompressible because it's literally changing volume. So, but we'll do, I don't know. What am I gonna say? Working gauge pressure. My fluids had to specify it in an assumption. It's not really an assumption, but don't look at that. Don't look at that. That's gonna make me depressed if I look at this. I'm moving it down to the bottom. How is this a second week, third year ME question? It's okay, it's okay, it's okay. I'm so normal. Okay. We just have to do it. We just have to do it. It's easy. It's easy. FPATM, and then I'll just write this out a little bit. So P times area equals, I'll say P internal times area equals E ATM times area. All right. Pressure equals force over area. Wait. Yes. I'm doubting myself. Now that I know I have like an actual person who understands what's going on in chat, I'm like, oh fuck. gotta keep up my game here. Okay. It wants it in pound inches, so I'll change the area into inches. That's easy. The doubter. So mean to me. Sorry, ignore me. No, you're fine. You're fine. I'm goofing. It actually is okay though, because This is not in. This is gonna be in inches squared. I'm just dividing the area, and then. God, I don't like that they don't specify pound mass, but it's pound mass. Pretend like I'm a music major. My roommate is an IE, and he's really good at music. So, oh no, now I'm imagining him. I'm fucked. Wait, feet per second squared. Feet per second squared. Come on, man. I'm just writing that. That's not what I need. 9.81. Unit conversion. My bestie. My bestie. Pretend I'm an English major. Okay. English majors are hardcore. What's your favorite time signature? Looks at smudged writing on my hand. 718. Wait, oh, that's not 9.81. Oh my god, don't. 4-4. How do you figure out the rhyme of the ancient mariner? Wait, rhyme of the ancient mariner. I know the name. Wait, we're gonna listen to the rhyme of the ancient mariner. Rhyme of the ancient mariner. Boring. Wait, is that the? Oh wait, no, that's not that's a poem. It is an ancient mariner, and he stoppeth one of three, by thy long grey beard and glittering eye. Now wherefore stoppest thou me? The bridegroom's doors are opened wide, and I am next of kin. The guests are met, the feast is set, mayst hear the merry din. That's kind of fire, actually. The guests are met, the feast is set, kind of goes hard. He holds him with his skinny hand. There was a ship, quoth he. Hold off, unhand me, grey-beard loon. Eftsoons his hand drop he. I don't know about that one. That one's a little eftsoons? Kind of doing too much, I think. In Damie Civilization, you can do a 1-block jump for a simple math problem, or 1-block vertical jump for a harder math problem. Eftsoons. What does eftsoons mean? Soon after. Archaic. Oh gee, I would never have guessed if it was archaic or not. Oh wait, we're actually... Oh no, I do have to change it. to... I think it's just 1 foot. Amy, please tell me you've seen that? I don't know what that... No, I don't know what that is. Is it a video? Damie's Gen Z? No way he hasn't. I must retreat, I must frolic. Bye. Bye, Rev. I don't know what that is. I really don't get a lot of references. I feel like we've established this. I didn't know what the... what did I not know about? I didn't know what demure... The first time I heard demure was by an adult saying it. In a joking way. Which is actually very funny that I managed to go that long without it. I'm messing something up here. Why is my... This should be in... pounds squared. mg feet per second squared. I've got... What the hell? I've got feet squared. My next door neighbor called my earrings demure unironically, and I panicked. Why are my units not uniting? It might be uniting actually. Pounds force per inches squared might be the same as this, because pound force is... It's like... It's meters... Wait, Newton meter is kg meters per second squared. That's a Newton. So it's pound mass feet per second squared. Do I have that? Yes, I do. But it'll be in inches. Please watch this live. Is it gonna be bad? I will watch it live if it's appropriate. It's a Twitter video. Okay, it's a Minecraft link. Okay, it's safe. You could just be saying that, though. I'm kidding. I'll watch it. I'll watch it for you, Umbra. Let's go over here. We're going on a trip.
The one block jump for the raw chicken, or you can attempt the one block vertical jump for the beef.
Parkour
What?
civilization.
Parkour civilization?
It's better to be safe and do the one block jump for the chicken rather than risk your entire life for just half a
What?
bar more.
Tomorrow, you better not be late, or you'll be doing 2 block jumps as
Whoa.
punishment.
Sorry, I won't be late next time. Down here, us parkour noobs only get fed once a day. One piece of raw chicken will get you to the next day. But that's
Wait, this is kind of...
parkour civilization.
This is scary.
You have to parkour. Every parkour noob has the same goal. To make it to the top layer where other parkour pros live.
This is like the 10th circle of hell.
If you're a parkour noob, there's only
Nope? You're parkour noob?
The Temple of Parkour. The Temple of Parkour is the only structure in the world that combines the bottom layer to the top layer. To make it up, you have to do
You have to parkour.
parkour course that
Okay, I see. But how do you practice parkour if you only one block jump?
to complete the course. The inside of the temple is protected by a barrier, and the only way a parkour noob gets past the
Noob.
is earned a ticket. I've never even tried getting a ticket before, but if I'm gonna rank up to a parkour pro one day, I'm gonna have it. In my neighborhood, pretty much everyone has fallen into the void and died. Except
Oh.
the guy who lives right next to me. He's been my neighbor
This-
for 5 years.
Her fault. Okay. That's how I feel. That's how I feel. That's just my day-to-day life right now, guys. It's just a day in the life of me as a EE noob. Thank you for letting me know. That's gonna be in my brain now forever. There's a 4-hour movie of this? Wait, but I'm kind of invested, I'm not gonna lie. How is there 4 hours of that? Is it just different people falling into the void? It's 2 2-hour videos. They're gas? No, it's gas? Okay. Maybe I'll put it in my watch later. Can we get a Truman Show, but it's Minecraft parkour civilization? It's genuinely so good. I'll watch it. I'll watch it. I'm not lying. I'll watch it. Did I convert this right? I don't know. It's probably more dystopian teen influenced. Yeah, it's like the Hunger Games. But if the Hunger Games was Minecraft parkour. This would be, let's see. That's just MG, so that would be, I'm just trying to think, pound mass, feet. Wait, it's feet per second squared, it shouldn't be feet, oh wait, yeah, feet per second squared, that's fine. And then, it's, yeah, except I think I need to do that 12 squared. I don't think I can get away with just that, can I? Why is my conversion factor, feet per second squared when foot fetish per second walks in? Yeah. American system is kind of fucked up like that. Like the tweet where it's like, a boat is 150 feet long. Feet starts... I'll let you finish that sentence. Why is my brain fried right now? What the hell? I need an inch squared. This is 144. I don't know why I was... Okay. Well, I'm glad it took me 20 minutes to do... That's not 20 minutes. 36.92. I love dimensional analysis. You know, I do like it. I'm a lot better at it after Civil and after Thermo. So I'm really not too... I used to be kind of annoyed at it, but it's really not too bad. Ever since, I think Fluids was the class where I was like, there is no way that I cannot do this. I have to do fully dimensional analysis, fully out. My biggest joy as a teacher is teaching students dimensional analysis? Really? That's... I don't know if it would be my biggest joy as a teacher. Oh my god, what is it? It's like multiplied by 9. 9/5 plus 32 or something. F to C. Minus 32 times 5/9. This reminds me of my first year ME where we had to do drafting, and a very common thing to do in drafting is teach you engineering lettering, which is writing a certain way. But when you're learning engineering lettering, generally the way that they teach you engineering lettering is to make you do worksheets where you write out and trace things, and it made me feel like I was in kindergarten, and this is the equivalent of that right now. Okay, that's not true. It's probably when they laugh at my jokes. Yeah, I like it when they laugh at my jokes. I like it when you guys laugh at my jokes, even though they're not very good. It's okay. No, not answer minus 22. What do you teach? Do you teach for college? There's no way they're forcing. My friend is grading for this class. She's gonna look at this. She's gonna be like, dude, what the f are you doing in this class? Why are you doing this? Oh, just a teaching assistant? Oh, that's so nice. I really want to do... I was thinking about TAing for a SolidWorks class, but I don't know if I have time to. Because I have to go to the SolidWorks class then, and that's it's not that I don't have time to TA for it, it's just that I don't know if I can actually be there. EML 20. What? EML? I don't know what that is. Oh, that was our class code for it. Wait, which like what's the name of the non-class code for it? That's 0 degrees Celsius. Negative 459 point. Okay, that's very specific. I think I just... Oh, engineering... Oh, CAD, yeah, so that's cool. I like CAD, it's fun. What's the most accurate? It's 273, but I don't remember, I'm assuming it's 273.15. Is it minus? No, it's plus. Like, that's specific enough where... I can't believe... I'm so sorry, chat. But we're just chilling out, so... I was doing... I was working on CAD for... Because I want to do... That's where I want to go for what I want to do for my job. I was doing CAD for this one furniture design. And it's like, you know when you're in like the beginning of the... Oh wait, why am I here? Wait, why did... I've been here for so... I just switched that? Oh my god, I'm not even comfy. There we go. I was doing CAD for this chair design, and it's in the stage where it looks so bad right now, and I'm like, I have to trust the process, but it just looks so ass, and it's like, okay. It's so hard trying to figure out how to, like... This one I don't need to do it. I was trying to figure out how to make it out of one piece of wood, and now I have to like do geometry for it and stuff and figure out how thick the block of wood needs to be, and it's like, man, I don't want to have to think about that. Let's see, 270, so that'd be 240? And then this one is like, what, 300? I love being an engineer. It's so hard, guys. You can do engineering too. Just do that. Apparently that's enough to pass Thermo 1. I'm forever gonna be salty about that. Wait, who's pinging me? Hello? Oh, Umbra is. Oh, Umbra sent me the Minecraft but I survive in Hardcore Civilization. Wait, is the Minecraft one, is it like a roleplay or is it like a scripted movie? Very important question. Swear to God, if our control volume analysis problems are like this for Thermo, I'm gonna cry. I miss Reynolds Transport. Take me back. Alright, we did that. I'm gonna try. Let's see if we can do. I'm probably going to wrap up a little soon, but I want to see if we can do some intermediate dynamics because that's actually hard. And oh, thank God he opened the class finally. Bruh. Bruh. He's crazy. He just opened it and we have a thing too. MATLAB on-ramp. MATLAB, my beloved, my be-hated. Oh wait, I have to switch the section. It's 04. Sorry, let me just quickly like rename a file on stream. You don't like MATLAB? I think MATLAB is just really funny to me because it's kind of just a fake language. It's not really anything. Uh-oh. I wrote on-ramp certificate. Is it gonna be mad at me? Yeah, it will. That's fine. I've been teaching a MATLAB class for the past 6 semesters. My intro MATLAB class was such a joke. What do you teach? What like kind of stuff do you teach for it? We actually, it's funny because the professor for this class was like, okay, who took the MATLAB class? And maybe like 80% of people raise their hands because technically you don't have to take it. And then he was like, and okay, so raise your hand if you learned anything from the MATLAB class. And then like no one raised their hand. It's computational linear algebra. Wait, that sounds sick as hell. Ours is literally just MATLAB. It's not even like do these specific things in MATLAB. It's just MATLAB. I don't like my courses very much. Some of them are pretty dumb. That one was pretty dumb. Some of them are okay though. I like my intermediate dynamics is fun. Damie, am I zen? I'm so zen. Intro to programming classes are a little useless. They just don't make you do enough. This one, I think the main issue was they didn't have us do enough. They didn't have us do enough projects. If it was like, what's the like case studies almost? And they were like, oh, like figure out how to make this thing work, then it would be great, it'd be fine, you know? But it was just like, it was like the thing where, because I've been programming for a while, and like I had to do, I've taken an annoying amount of like intro to Java again, because we're not giving you credit for this thing, or whatever. And it's just like, it's all like so much about syntax, and you don't even like remember the syntax because you're not using it all the time, and then you don't learn anything. Okay, we're doing rotating axes, which is really cool. It's very easy. Essentially, we just have, instead of having a fixed axis, our axis rotates. That's what we're gonna do. And so, when we have a rotating body that, learn what a while loop is for the 10th time, oh my god, you're so real for that. So these are really good when we have a combination of rotation and radial motion, or we have, yeah, basically if two objects aren't rigidly connected, but they can kind of move with respect to each other, away from each other. So that's when it's good to use rotating axes. And right here we have a little slider, so we could do this with polar coordinates and fixed axes around A, but it's a lot easier to just use rotating axes this way. So we're gonna set up our rotating axes here. I'm gonna draw that first. This is our little Y. And this is our X. So there's a different equation or a different setup of variables for our rotating axes if we're doing velocity with them, because we'll have, I believe it's written like this. So if we want to say v of p, it's going to equal v of a. So if a is moving around, that's still similar to the rotating. Plus, we're going to have a big omega, which is our rotating axis velocity, cross rp with respect to a. That's kind of the same. This is like normal relative motion. But then we can also have an r, x, y, z of p. And that can be changing. So it can be doing whatever it wants to do, its own little motion, apart from a, but we basically just kind of lump that in there. And that's literally all the rotating axes is. That's our governing equation for that. Anyway, let's look at the problem. Rod OAB is rotating counterclockwise. So we have OAB. Oh, it's one big rod. Okay, well, whatever. An L thing. Rotating counterclockwise with a constant angular velocity. Constant, thank you. Oh yeah, because we haven't done acceleration yet, which I'm assuming is going to be a very long equation. Of 5 radians per second counterclockwise. In the position shown, color P is sliding towards A with a constant speed of 0.8 relative to the rod. Find the velocity of P. Alright. Now we're to specify the rate of rotation of the rotating axes. So in our givens, which I don't like writing, say that every time, mumble mumble. On OAB, so we're given omega OAB. I'm going to call that omega O. And then, what class is this? This is dynamics. I do a lot of multi streams, and I switch between them. In the VOD, I tend to split them up into sections, but in live, I just go, oh, I want to do this other random thing right now. This is not the same class. Dude, that would be so cool. Thermodynamics dynamic class. Oh my god, we have like spinning gases and shit. That would be so cool. That's just like computational fluid dynamics, I think. Oh, I would be so into taking that, but it's like a 500, it's a grad like level course for us, I think. I don't remember if I remember any dynamics at all. Honestly, I thought I wouldn't remember as much, but I kind of remember more than I thought. And then we're given like the R, X, Y, Z. Now, yeah. The rate of change is going to equal... Okay, in our coordinate system, it's going to be negative Y. So 0, negative 0.8. 0. And then are we given anything else? Not really. And then we want to find... I don't know. I want to find something. I want to find VP. Just remember that you had to change a frame of reference like 6 times for problems? What? Wait, we don't have to do that. I mean, maybe for more complex ones. Oh. Yeah, I don't think we have to do that. VA is going to be omega cross R. So omega O cross R, A with respect to O. Ooh, we're not given an angle. Okay, 6 is an exaggeration. Maybe 2? Do you mean reference like your relative velocities? Like with respect to A or something? What is omega? Omega, well, big omega is little omega. Probably? Okay, that is, yeah, that's true. RA with respect to B. Do we have any values here? Low-key, no. Wait, how do we not know values? Do I have to do geometry? No, don't make me do geometry. Wait, but I don't know how long A with respect to B... Wait, no, A with respect to O is. Because I don't know the angle. Wait, what? So we're doing stuff like a plane flies by double pen... pendulum, and then you have to calculate the relative velocity. Oh, yeah. Sorry, I was just imagining. I know what you mean, but I just think it's really funny. Like a plane is just flying by, and you just have a double pendulum on the ground, and it's just like, find the relative velocity. Like, that's such a dynamics ass textbook problem. Okay, I don't know if we can get. Wait, sorry, that's not A with respect to O. That's P with respect to A. I don't know how far away it is. Do we need it? Let's maybe... Okay, wait a second. We can maybe cross-product it out. So if we have R, let's just call this RP with respect to A. Yeah, I don't know why. We know the direction it's in, at least, I guess. Well, we have the distance P with respect to O. Why? Why do we have that? Okay, whatever. Sometimes things wash out in the cross products. So we want 3. It's not normalized. 3 over... okay. I'll normalize it down here. I do everything very mathematical because I don't like not doing it mathematically. It makes me feel gross. Wait, it's just a 5. What am I talking about? 3, 4, 5. Easy. Wait, but is this in our... This is in our... Oh. Oh, yes. Okay, so this is in our rotating. Oh, I forgot. It all needs to be in our rotating axes. Because Omega O is fine, but RP with respect to A is going to be just... It's not going to be like that. Look. It's going to be in this direction. There we go. And then we know that this is 0, negative 0.8, 0. Yeah? Yeah? And do we know anything about VP? Well, we don't really know anything about VP. So we can't say that. Do we know what direction VP is supposed to be in? I guess not really either. So we'll just leave it kind of open. 005. Oh boy, my tablet. Okay, and then A with respect to O in terms of these coordinates. Oh, it's just going to be in the X direction. I don't know what it is though. We don't know anything about VP. I feel like I know a lot about Combo right now. Oh, that's funny. Isn't there a vice presidential debate today? I think so. Oops. RA with respect to O, and then we'll just pray that works. This is what I'm forcing my students to laugh at. I feel like I really enjoy laughing at professors' jokes. Like some people are like, oh, I feel like I'm forced to laugh, but it really doesn't take a lot to get me to laugh at somebody's joke. I think it's just because when I'm in the space of a lecture, I'm like, oh, I know when you're like trying to be funny, and like it just makes me happy that they're happy, I guess. Let's see if this is gonna work out. So we're gonna have, this is a negative, so it's gonna end up, we end up with positive RA with respect to O. 5, 5, 5, 5. I'm so bad at forgetting those first constants. And then this one is similar, except it's in I. It's negative I, so negative 5 R pu. Wait, we might be kind of chilling. Wait, no, we're not chilling because we're trying to find V. So if I can get these values, then we're chilling. But like, right now we're not really chilling here. How do I get these? A with respect to O? I only have 300 millimeters here. I don't have an angle. What? I know this is 90. Or I'm assuming it's 90. Oh, do I have to like transverse line? Transverse line. On the day when it was raining, I left the room to get some water. When I came back, as soon as unfortunately the rain stopped, so I had to use the water fountain. No one laughed. Okay, if somebody came in and said that, I think I would just be like a little like flabbergasted. I would be like, oh, okay. They just looked at me. No, it's okay. Undergrads are just like dead inside. Don't worry about it. Speaking as an undergrad. Is this also a 345? I'm just gonna go out on a limb and say that it's 345. I love the fact that I just... It's 3. I just started doing math. No. 60 times 3, 180. We're gonna pretend that it's a 345. Wait, that's not the 180. This one would be the 180. And then I think it has to be 343. I think it has to be 345. I think it has to be 345. I was like, oh fuck. See, why couldn't we just say the geometry? Why do we have to, like, I'm fine with the geometry coming in like hard on the second problem, but like, come on. Give me a little bit of an easy angle or something to do, just so I know that I'm doing it right. That means RA with respect to O is 240. So this would be... Well, let's see. Negative 5 times 180. That one... Oh, meters per second. Okay, maybe we're chilling. So we are not chilling, chat. At all. 900 at 0.9. So the question is now... Let's see, what about the 240? Was the 240 also times 5? What did I have? I had RA... Oh, wait, no. RA with respect to O minus... Wait. That's 240 times 5 minus 0.0... No. It's a little bit different. Divided by 1,000. No, not 1,000. Yes, 1,000. 1.2 minus 0.8. 0.4. Okay, no. Both of them are very wrong. Let's maybe change them to meters. First, 0.3. But then that wouldn't really, would that fix my problem? It'd be 0.3, like 0.24, 0.18. Let's just check it. I'm getting 0.9, which is close. I mean, it's rounded, but that is probably just a coincidence. And the other one would be 5 times 0.24 minus 0.8. 0.8. 0.4. Yeah, that one's not right. Probably a geometry thing. Let's see, if this is this... I know that... Do I know anything about... Wait, yes, I can find this angle. So 345, this is 30, which means that this is 30, so this is 60, so this is 30. Yeah, so it is 30, 60, 90. Do I take my E now? Well, what kind of E do you take? Is it like... oral? Is it whatever? If it, well, I also don't know what time zone you're in. The answer is probably yes. Wait for my friend to interrupt me like he does every time. I mean, don't have your friend interrupt you. I always do my gel at night. I'm on T, not E though. Wait, so it is 30. Maybe I just fucked up? Wait, maybe I actually just fucked up. Wait, 0.3 cosine 30. Oh wait, no, I I just can't do 345 and divide it by 5 and multiply it. Guarantee? How do you sleep after all that caffeine? It's cute. I've only had one tea that I liked, and I don't know what it was. Which is forever sad to me because I don't like most of the teas that I try. Well, fuck. I think I got it right then. 0.3 cos 30 is 0.259. So VP equals... This is 0.259. And then sine... Come on. Sine 30. 0.15. So... if I P respect to A is that one, so 5 times 0.15 is also not right. That's worse, 0.75. The fuck? I could have done my cross products wrong. That is a very possible thing. Or I could have not converted right, which is also possible. What about the other one? 5 times... The other one seemed like possible. 0.5 and then minus 0.8. 0.495. No, that's also off. Okay, it's definitely a geometry thing, but that's just like embarrassing that I can't do the geometry. Lol. Like it should be 300 cos 30. Wait, am I in radians? That's what it was. Wait, am I in degrees or radians? It's hard for me to tell on this calculator. No, I was in radians. No, I was in degrees. Wait, what? Yeah, I was fine. I don't know. 300 divided by 5 times 3. No, that's what I did before and that was also wrong. It should be cosine 30, sine 30. So PA is the 300 sine 30, which is 150. Why 30? Because this angle is 30. Because if we shift this down, this is 60, this is 30. Right? Is a 3, 4, 5 triangle 30, 60, 90? Wait, that's not right. Wait, what the fuck are the angles in a 3, 4, 5 triangle? Wait. What are the angles? Wait, angle 3, 4, 5. Stop. I mean, I guess I don't really need it. I guess I could just do sine would be 3 over 5, right? So 300. Wait, but I was wrong that time. 300, because I did 300 divided by 5. 300 times 3 divided by 5. 180. That's this one. And then 300, or I guess like 0.18. How does she have more precision than this? 300 times 4 divided by 5. 2.24. That's what I had before and it was wrong. Maybe my cross products are wrong. Or maybe I'm not normalizing or something? Maybe my directions are wrong. There could be many things that are wrong. Like 5 times RAO is, let's see, 5 times 0.24. Yeah, I'm definitely off somehow. Alright, I'm gonna say that it's probably... It's probably some geometry thing, so I'll have to check it later. But I gotta go do some stuff. So I'm gonna end. I normally don't stream for that long. But wait, somebody's... Goodbye. Okay, I am gonna be streaming again on Thursday. And we're probably gonna do... Well, I guess I don't need to do thermal. Might be... It's probably more intermediate dynamics. And maybe some EE. Man, I need to... Bro, I need to catch up my EE so bad. I'm not very good at it. But it was very nice. Oh wait, let me... I think I'm gonna say next lecture. I start learning thermal next lecture. I looked at the textbook, and I'm pretty sure we start learning it next lecture. But if not, I'm gonna refund the points. But yeah, we'll be doing more of this, and hopefully I'll figure out why this is weird. You know, there also is a potential that her answers are wrong. It's small potential, but it's happened before. So, you know, this is also possible. But congrats to everybody who predicted. Let's hope that it's next lecture. I'm gonna lose my mind if it's not. Alright. I hope everybody has a lovely day. And eat some good food. And I have my 6 to 7 p.m. intermediate dynamics activity now. OMG, I'm rich. You can redeem so many metal pipe and chicken on screen and sparkle on and all my redeems. Right, bye everybody. I'm gonna end stream now. Bye.